Good day, everyone. Welcome to the second part of Cambridge International Examination AS and A level Physics Paper 2 Variance 1, May June 2023. If you are following my YouTube channel, you by now you see you solved question 1 to 4. So question 5. An electromagnetic wave has a wavelength of 8.4 times 10 to the minus 6. State the name and the region. State the name of the region of electromagnetic spectrum of the wave. Okay, the name of the region, it belongs to ultraviolet. It belongs to ultraviolet. Ultraviolet is always in the region of 10 to minus 6 to 10 to minus 8. To check your book and memorize this. So calculate the frequency in terahertz. So terahertz means 10 raised to the power 12. And the wave speed is f lambda. We are looking for frequency. Frequency is, instead of v, we are going to use c over lambda because we are dealing with electromagnetic wave. All electromagnetic wave move with the speed of light. So in that case, speed of light is 3 times 10 to the power 8 divided by frequency in this question, 8.4 times 10 to the power minus 6. So end frequency. If you divide 3 divided by 8.4, I have 0.357 times 8 plus 6, that's 14. So frequency, this decimal point move in 2 places. It becomes 35.7 because it moved in 2 places. I have a power of minus 2 because it's moving backward. Already we have power of 14 before. At the end of the day, frequency turned 35.7 minus 2 plus 14 is 12, and 10 to 12 is tera. So the frequency is 35.7 terahertz. The next question. An arrangement that is used, that uses a double slit to demonstrate the interference of light from laser is shown. We have the wavelength given, slit A, the screen. Distance between the slit and the screen D is given as this is 2.8. Question says that an interference pattern of white fringes, bright and dark fringes occur here on the screen. So instead of showing it on the screen, they show us horizontally. This is horizontally. So the distance on the screen across 8 bright fringes is 22 meters. The colored one is dark, while the space is the bright fringes. That's what they use in representing it. Now, the first question: what is meant by coherent source? The light wave emerging from the 2 states are coherent. What is meant by coherent source? What is meant by coherent? Coherent means constant phase difference. Coherent means constant phase difference. Constant phase difference. That's the meaning. And same frequency. Constant phase frequency and constant phase difference and same frequency, or the phase difference does not alter with time. Write that too. Or phase difference does not altern with time. Any one of them is allowed. The next question, calculate A of the slit. Already from the question, we're given D to be 2.8 meter. From the question, I think I saw wavelength of 6 point something. Let me check it. 6.2 times 10 per minus 7. And also from the question, we are looking for A. We are looking for A for X. X is not specifically given. And you check the question is 7. The question said 8 bright fringes. And you check the question said 8 bright fringes is 22 meter. Is it? 8 bright fringes is 22 meter. But to use the formula, we only need one bright fringes. If 8 bright fringes is 22 millimeter, so 1 bright fringe will be 22 divided by 8 in millimeter, which will give us 2.75 millimeter. So our X is 2.75 millimeter. So using the formula, the Young double slit experiment, using the formula, lambda equal to AX over D, and we are looking for A. So A is lambda D over X, and lambda is 6.2 times 10 raised to the power minus 7. D is 2.8, and our X is 2.75 millimeter. That's times 10 to the power minus 3. So which gives us, let's do the calculation, 6.2 times 2.8 divided by 2.75, 6.31. So A is 6.31 multiplied by 10 to the power minus 7 plus 3 minus 4. That is A. Next question, fringe P. Fringe P is the central bright fringes of the interference pattern in B. In B. Okay, this is B. Interference pattern, they said P is the central. P is the central. P is the central. You know what is meant by central? Fringe Q is the nearest dark fringe. Fringe R is the nearest bright fringe, respectively to the right. See, to the right of fringe P, which means they are on one side of fringe P. They are not on both sides. They are on one side. To the right of fringe P. To the right of, they are on one side of fringe P. Okay, let me show you what kind of skeleton diagram of what the question is trying to tell us. You know, it's two slits. Let's say this is a screen. As you see from the question, let me use different color. P is the bright fringe, according to the question. So Q is the nearest dark fringe. Q is the nearest dark fringe. This is Q in blue. The nearest dark fringe is R. And remember that both Q and R, they are on one side of P, on the right hand side. They're on one side. They are not on the other side. They are just on one side. They made it clear. So the question said that we should calculate the difference in distance, path difference from each slit. Let's say this is slit 1, X, Y another slit. So distance from each slit. Look at the question. Distance from each slit to the center of fringe Q. And you take this slit at X, you take it to the center of fringe Q. Take another slit to the center of what? Fringe Q. So the distance we are looking for is kind of XQ minus YP. This is the path difference. Since Q is a dark fringe, so you're going to give us the general formula for dark fringe, N plus R bracket lambda. This is general formula for dark fringe. What is the position of Q in dark fringe? According to the question, Q is the immediate nearest dark fringe, and N is the order. N can be 0, 1, 2, 3, blah blah blah. So when it's 0, 0 means it's the immediate or the first dark fringe. So in this case, XQ minus YP will be 0 plus half lambda. So X cubed minus YP is the path difference PD, which is equal to half lambda. So and our lambda, when you check the question earlier, our lambda I think it's 6.2 times 10 to the power minus 7. Half of it will give us 3.1 times 10 to the power minus 7. That is the difference in distances according to the question. Now state the phase difference between light wave meeting the center of fringe R. Fringe R is the nearest dark bright fringe. So I should state the phase difference. Since we are dealing with bright fringe, so the phase difference is 0 degree. Number 6, a metal wire. A metal wire in a circuit has length. Of course, you can see the length 1.8 meter. You can see the area. The charge carrier is given as this. So there's a current passing through that wire. So the charge at that point is 172 coulomb. The time is 2.5 minutes. Show that number density is this. First, what is the formula for number density? It's one of the steps when you are deriving an average drift velocity equation. Formula for number density is number of charge carrier, all over volume, and the volume is area times length. So number density, charge carrier, as you can see in the board, 2.3 times 10 to the power 23. Volume is area times length. Area is 1.5 times 10 to the power minus 6. Length is 1.8. Do your math, use your calculator, is going to give us 8.5 times 10 to the power 28 meter per meter cube. The next one, calculate the average drift speed of the free electron. Recall that I equal to AN VQ, where V is the average drift speed of the I over A and Q. We have area, we have number density N, and we have charge 1.6 times 10. But we don't have current, since Q equal to IT, I is Q over T. So our I and the charge here, the charge that passes through the wire is 172 coulomb. The time it passes for the time of 2.5 minutes, that's 2.5 times 60. So at the end of the day, our current is 1.147 amp. 1.1. So current is 1.147 amp. So we can now substitute the current. Sorry, I need to write it clearly. And to write the current clearly, current is 1.147 amp. To substitute the current in the equation to calculate V, that'll be 1.147 over area 1.5 times 10 to the power minus 6 N 8. Okay, 1.5 times 10 to the power minus 6 N is 8.5 times 10 to the power 28 multiplied by Q, the charge on electron, 1.6 times 10 to the power minus 19. So V will be 1.147 divided by 1.5 times 8.5 times 1.6. I think 20.4. We have 20.4 multiplied by 10 to the power minus 6 minus 19 minus 25. That will be 3. At the end of the day, 1.147 divided 20.4. So we have 0.056 times 10 to the power minus 3, which becomes 5.12. 5.6 times 10 to the power minus 5. Average speed. And number 7, a battery of electromotive force, EMF 9.6 volts. The EMF at the source of voltage is 9.6 volts. Negligible internal resistance, so no need of considering internal resistance. It's connected in series to two fixed resistor thermistor. Is connected in series to two fixed resistors and a thermistor as shown. The fixed resistor is governed, that's 3,400. The fixed resistors are resistant 3,400 ohms and 5,000 ohms. The reading on the voltmeter, the reading here is 6 volts. Calculate the current in this place. Okay, let's make it easier. Since this is the EMF 9.6, every other voltage is from this 9.6. So 9.6 will be equal to the sum of the voltage in the circuit. This 9.6 will be equal to the sum of the voltage in the circuit because every other voltage is from this EMF. That will be 6 volts plus 5,800 multiplied by I. So from here, I have 9.6 minus 6 equal to 5,800 I. That will be 3.6. 9.6 minus 6, that's 3.6 equal to 5,800 I. So I is 3.6 divided by 5,800. That gives 6.2 times 10 to the minus 4. That's it. Calculate the resistance of the thermistor. The resistance of the thermistor. Okay. Now this is the thermistor. Let me call it T, the thermistor, resistance of the thermistor. You know, this thermistor and this resistance, they're in parallel with this voltmeter. This voltmeter, 6 volts, which means the voltage across them, the sum of voltage across 3,400 ohms and thermistor should be 6. So 6 equal current times 3,400 ohms plus R. So 6, and the current in the circuit is 6.2 times 10 to the minus 4 bracket 3,400 plus R. So at the end of the day, our R, you do your math to give you 6 to, let me check it, 0.0062 1, 2, 3, 4 divided by 6. We have that. You do your math. R should be 6 to 77.42, approximately 6,300 ohms. That is our R. Oh, I call it, I label it T in this question. Okay, let me leave it as R. The resistance of the thermistor. Let me leave it as RT. Resistance of the thermistor. Leave it at RT. Okay. Next question C. The initial energy stored in the battery. The initial energy stored in the battery as the work done is 2.6 times 10 to the power 4 joule. Assume the EMF of the battery is constant. EMF is constant, or which is 9.6 volts. Determine the final energy stored in the battery after a charge of 330 coulomb has moved to it. Final energy. Since remember that V is work done over charge, which is also the same thing as E equal to work done over charge. Now, they said the EMF is constant, so it's 9.6. What is the energy? Why the charge is 330? I don't know. Let me look for it. So why the charge is 330? The energy is 9.6 times 330. At that point, the energy will give us 31. Let me use my calc. 9.6 times 330. 3168. Hence, the final energy will be 2.6 times 10 to the power 4 minus 3.3.168 times 10 to the power say 1, 2, 3. So the final energy will be 2, 6, 1, 2, 3, 1, 2, 3, 4, minus 3, 1, 6, 8. So the final energy 2, 2, 8, 3, 2, which is 1, 2, 3, 4, 2.28 times 10 to the power 4 joule. So the final energy decreases after a charge of 330 coulomb has moved through it. So it will fall by this amount. That's it. Question D. The environmental condition change causing an increase in the resistance of the thermistor. State whether there's a decrease, increase, or no change to temperature of the thermistor. Or the temperature of the thermistor will decrease. The environmental condition change using increase or resistance of the thermistor. When you increase the resistance of thermistor, the temperature of the thermistor decrease. Current in the thermistor also decrease. Remember that we decrease resistance. We decrease the environmental condition change, increase in resistance of the thermistor. Okay. Potential difference across the thermistor will increase. Remember that will increase. Remember that the resistance of thermistor is the negative temperature coefficient. So when the resistance is high, temperature will be low. At low temperature, there will be low current. That's why this is decrease. And at low current, there will be high potential difference. That's why this is decrease. The last question, question 8. An isolated stationary nucleus X decay by emitting alpha particle to form a nucleus Y. To emit alpha particle to form a nucleus Y. Nucleus Y and nucleus Z are isotopes. By comparing the number of protons in each nucleus, state and explain whether the charge of the nucleus is less than or greater than the same of the charge of the nucleus Z. Remember that said by nucleus Y and nucleus Z are isotopes. What are isotopes? Two or more forms of the same element that contain equal number of protons but different number of neutrons. Equal number of protons, since Y and Z are isotopes, it is expected that they have the same number of protons. So once they have the same number of protons, so they will have the same charge. Yes. So since they are isotopes, they have same number of protons, so they have same charge. Nucleus X. Nucleus X is the one that decay, right, into alpha particle and Y. Obviously, since X is the one that decay, X has higher number of protons. X has a higher number of protons. So X has higher charge. The last one, use the principle of conservation of momentum to explain why nucleus Y cannot be stationary. Okay, remember that, let's assume this is X. X decay into alpha particle 4, 2. So this alpha particle, the remaining one will be a minus 4 and z minus 2. This is y. And the question said x is stationary. If you check it, it said isolated stationary nucleus x. If x is stationary, momentum of x will be equal to 0. If you are going to use principle of conservation of momentum, which means momentum of alpha plus momentum of y should be equal to 0. How will they be equal to 0? Only if momentum of x, momentum of alpha, is equal to opposite of momentum of y. This is how conservation of momentum can be obeyed. I believe you understand what I'm saying. Since momentum of x is 0, so if we use principle of conservation of momentum to explain why nucleus y cannot be stationary immediately, not that nucleus y will not be stationary, but immediately it won't be stationary immediately, but will eventually come to rest. Now let's look at it like this. Initial momentum of the system, is 0. Thus, according to the principle of conservation of momentum, POCON, the final momentum must be equal to 0. The final momentum must be equal to 0. But the question said, explain why nucleus y cannot be stationary immediately. Yeah. Nucleus y cannot be stationary immediately. Because let's say it. So hence, since the final momentum must be 0, how can the final momentum be 0? Hence, momentum of the alpha particle must equal to momentum of y, but in opposite direction. At the end of the day, momentum of alpha particle plus y equal to 0, which means after decay y has a little momentum before coming to rest. That should suffice with the analysis. Okay.